Hey everyone, welcome to How to Find the Definite Integral. This is Flipping with Bennett. So we've talked about how to do antiderivatives of indefinite integrals, and now we're switching gears. And the difference between really the indefinite integral and a definite integral is now you have a boundary, a lower and an upper limit of integration, okay? So I made some videos on how to find the area on a curve using left, right, and midpoint Riemann sums of x squared. So let's actually find the area of x squared on the interval from 0 to 4. So the great news is you really just integrate this the same way as you would do an indefinite integral, okay? So you take the integral of x squared, it becomes x cubed over 3, right? Power rule, you add 1 to the power and divide by that same number. Okay, normally you'd put the plus c here, but now we have from 0 to 4, so we're going to put 0 and 4 here. Those are our upper and lower limits. You're going to plug the upper limit in first for your x value. So we're replacing x with 4, so you get 4 cubed over 3. You're always going to subtract off that lower limit of integration. Okay, so you plug in 0 for x now, you get 0 cubed over 3. 0 divided by any number is 0. So you get 64 over 3, okay, which is 21.333 repeating. So that's the area under x squared from 0 to 4. Okay, that's the exact area. All right, so hopefully you're familiar, if you're watching these videos, you should be familiar with all these antiderivatives that we've taken, all these different functions. So here's a trig function now. And we're going to integrate from 0 to pi over 6 of secant theta tan theta. So I write my problem out. And again, the first thing you do is just ignore the upper and lower limit. You got to find the antiderivative. You got to integrate first. So the function that gives us secant theta tan theta d theta, that derivative is secant theta. So I'm going to have secant theta here, and that's going to go from 0 to pi over 6. Now, we're going to plug in pi over 6 in for theta, so secant of pi over 6 minus secant of 0. Okay, so now we have to simplify this. Now secant is 1 over cosine, so the cosine of pi over 6 is root 3 over 2, so this becomes 2 over root 3 minus secant of 0. Okay, cosine of 0 is 1, so this just becomes 1. I'm not going to simplify this by rationalizing, you could, but here's our area. That's the area under the curve from 0 to pi over 6 of secant theta tan theta. Our third example involves e, okay? E to the 4t minus 3, and we're going from 2 to 3, so 1 unit, okay? So again, I write my integral from 2 to 3 of e to the 4t minus 3. Okay, when you integrate this, this is just e to the 4t minus 3, the power rule, you divide by 4. And you're going from 2 to 3. You're plugging 3 in first. So you have e to the 4 times 3 is 12. 12 minus 3 is 9. So e to the 9th over 4. Minus, you plug in 2. 4 times 2 is 8. 8 minus 3 is 5. You get e to the 5th minus e to the 5th over 4. There you go. I'm not going to simplify that. You could on your calculator get a decimal, but there's the area under the curve. Okay? And our final example of applying these rules. So you get negative 2 to negative 1 over of the integral of negative 2 to 1 of 1 over x cubed. So again, I rewrite this. The only big difference here is you got to plug in your upper and lower limit of integration. We're going to rewrite this. You could do it as negative 2 to negative 1 of x to the negative 3 dx. Integrate that, you're going to add 1. Okay, so you're going to have x to the negative 2 over negative 2. So this integral becomes negative 1 over 2x squared from negative 2 to negative 1. You plug in negative 1 first. So you're going to have negative. You plug in negative 1, you get a positive. So you're going to have negative 1/2 minus, then you got to plug 2 in here, minus negative, and you plug 2 in, you get 4. 2 squared is 4, 8. So minus 1/8. Okay, and that becomes positive, so you have negative 1/2 plus 1/8. Okay, and so you get negative 4/8 plus 1/8, which is negative 3/8 is the area under that curve. Okay, so that's how you find definite integrals of a few different examples. Okay, we'll talk more about this in class. If you have any questions or comments on what I did here, go ahead, type them below, and we'll see you next time.